Happy morning, students. Welcome to grade 10 mathematics class. In the last session, we derived one formula. It is based on the relationship between LCM and GCD. Do you remember that? Yes, f of x into g of x equal to LCM into GCD. Based on this formula, we are going to solve the remaining problems in exercise 3.3. Listen, this is chapter 3, Algebra. Now the subtopic is relationship between LCM and GCD. This formula, the last session we derived, LCM into GCD equal to f of x into g of x. Now exercise 3.3. First Roman and second Roman, the last class we finished. Now third Roman, second question. Find the GCD of each pair of the following polynomials. So let we take this as first polynomial and the second is second polynomial, and also given LCM is one more polynomial. We need to find the GCD. Shall we do this? First need to write the given data. What are the data given? F of x is the first polynomial. F of x equal to x cube plus y cube. Then g of x equal to x power 4 plus x square y square plus y power 4. Shall we reduce this into simplified form? So x power 4, how can we simplify this? X square the whole square plus x square y square plus y square the whole square. Just see this. Is it in the form of a square plus 2ab plus b square? Just check this now. If we consider this as a square, here also plus b square, and which term is missing? 2ab term. That means we need two terms here, but here only one term. So if we add x square y square, then we can write it in the a plus b the whole square form. So for that purpose, I am adding one x square y square. Is it possible to add a number without subtracting that? Suppose if we add 5, surely we need to minus 5. Then the value remain unchanged. You got the concept? So here I need one more x square y square. For that purpose, I am adding one x square y square and I am subtracting one x square y square. So the value doesn't change. Listen. X square the whole square plus x square y square plus y square the whole square. I need one x square y square. So I am adding. I need to subtract that also. So x square y square. Now the value not changing. So now listen. X square the whole square plus x square y square plus x square y square. Two terms are there, no? So 2x square y square plus y square the whole square. Now I am writing this minus term in the next line. So minus x square y square. Now compare this first three terms to a plus b the whole square form. Check that one. A square plus 2a again. Then b plus b square. So if we put a equal to x square and b equal to y square, then we can apply which formula? A plus b the whole square, which is equal to a square plus 2ab plus b square. So this is in this form. A square plus 2ab plus b square. So instead of this, we can write a plus b the whole square. Here a equal to x square plus b equal to y square. Then this whole square minus this subtraction, okay, minus x square y square. Shall we write this as xy the whole square? Okay. Now listen carefully. Here on total, here this full bracket, considering this full bracket is a square minus this full bracket is b and b square. What is the identity we need to use? A square minus b square, which is equal to a plus b into a minus b. So here a equal to, inside the bracket full term also a. So x square plus y square and b equal to xy. So by applying this formula, listen, this one a square minus b square. So a plus b into a minus b. That formula I am going to write. X square plus y square plus xy into x square plus y square minus xy. Okay, listen. We resolve f of x and g of x, and this is the given data LCM. But we need to find GCD. And shall we use the relationship between LCM and GCD formula? What is that? F of x into g of x equal to LCM into GCD. We need to find GCD. So let it be this side. So f of x into g of x, while transposing LCM from this side to this side, that is, it is under multiplication relation. So coming this side, it will be as division. So LCM. Shall we calculate this? So f of x equal to x cube plus y cube. G of x is x square plus y square plus xy into x square plus y square minus xy whole divided by, what is LCM given? X cube plus y cube into x square plus xy plus y square. Any possible way to cancellation? Yes, x cube plus y cube, x cube plus y cube. And again, x square plus xy plus y square. The numerator also x square plus xy plus y square. So this term also we can cancel. So what is the GCD we got? X square plus y square minus xy. So this is the final answer. Got the point? Now see the fourth question. Just listen the question. Given the LCM and GCD of two polynomials p of x and q of x, find the unknown polynomial in the following table. There are two problems. First one we are going to solve. First one is LCM is given, GCD is given, one polynomial value given, and another one we need to find. Shall we do this? This also the same formula. What is that? Repeat the formula. F of x into g of x equal to LCM into GCD. Here, in the place of f of x and g of x, the polynomial name only changed. What is that? P of x and q of x. So, we can rechange the formula as P of x into q of x equal to LCM into GCD. The same formula only. Shall we do this now? Listen, the given data I wrote. So, given LCM equal to one polynomial. This is the cubic polynomial. And GCD is the linear polynomial because power 1. And f of x is the quadratic polynomial. The quadratic polynomial easily we can solve into factors. Shall we solve this first? So, So what is the product? 35. What is the sum? Minus 12. When we multiply, we need to get 35. And when we add, we need to get minus 12. Guess the possibilities. Minus 7 and minus 5. Is it possible? Yes. So what are the factors? A minus 7, A minus 5. We need to find the polynomial Q of x. So what is the formula we need to write? F of x into G of x equal to LCM into GCD. This is the general formula. We know that. Here P of x into Q of x equal to LCM into GCD. So here we need Q of x only. Let it be this side. So Q of x equal to LCM into GCD divided by P of x, which is equal to, shall I write the LCM here? What is the LCM given? Yes, a cube minus 10x square plus 11a plus 70. So a cube minus 10a square plus 11a plus 70 into GCD. See in the top, a minus 7. So a minus 7 divided by, what is P of x? We already resolved into factors. So a minus 7 into a minus 5. Is there any possible cancellation? Yes, a minus 7 and a minus 7. Then here one new thing. We need to divide this. What is that? A cube minus 10a square plus 11a plus 70 divided by a minus 5. Already in the last year, 9th standard, you have learned about how to divide polynomials by which method? Long division method. That method only we are going to use. We are going to divide this by long division method. That is the bigger polynomial. That means the numerator I wrote inside, that is dividend, and here a minus 5 is the divisor. We are going to find the quotient. Shall we do now? So what is the first step? Here first term divided by first term. So a cube divided by a. What is the answer? A square. We need to write in the top quotient section. So a square. Now we need to multiply this a square by each of this term. That means a square into a minus 5. What is the answer? A square into a cube minus a square into 5, 5a square. I am going to write here. So a cube minus 5a square. Now we need to change the sign. Correct. So minus, here plus. And a cube minus a cube get cancelled. So here minus 10 plus 5. What is the answer? Minus 5a square. One term we can write here. So plus 11a. Then same method only we are going to follow. The same steps. What is that? Step 2. This first term divided by again this first term. So minus 5a square divided by a. And here 1a and here also 1a will cancel. What is the answer? Minus 5a. So minus 5a. And this number into the divisor. So minus 5a into a minus 5, which is equal to minus 5a square minus into minus plus. 5 into 5, 25. I am writing here. So minus 5a square plus 25, a. Here also I am going to change the sign. So plus here minus. And minus 5a square plus 5a square gets cancelled. Here also 11a minus 25a. largest number having the negative sign. So minus 14a. And the last number I am taking now plus 70. And what is the third step? The same procedure. First term divided by first term. Minus 14a divided by a. What is the answer we will get here? Minus 14a divided by a. Minus 14 only. So minus 14. Now minus 14 into the divisor. So minus 14 into a minus 5. So minus 14a plus 14 into 5. 14 5s are. What is the answer? 70. Correct. So here minus 14a plus 70. Now I am changing the sign. So both the terms will cancel and we are getting the remainder as 0. So what is the quotient we got? This is the quotient. A square minus 5a minus 40. Shall we write the answer now? So we got the answer as a square minus 5a minus 14. This is q of x value. This is a quadratic polynomial. Shall we reduce into factors? So multiplication factor is minus 14 and addition factor is minus 5. Guess the numbers. Which number will satisfy this? Yes, minus 7 and plus 2. So minus 7 2s are minus 14 and minus 7 plus 2 minus 5. So we are writing the factors as a minus 7 and a plus 2. So this is the required polynomial q of x. That's all the answer. Now see the second problem in Roman number 4. Okay. What is given? LCM equal to x square plus y square into x power 4 plus x square y square plus y power 4. Then GCD is given x square minus y square. One polynomial value we need to find. Another polynomial value is given. This also the same formula. Repeat the formula now. Here p of x, q of x given. So we need to tell it as p of x into q of x. So what is that? P of x into q of x equal to LCM into GCD. Okay, shall we solve this now? So LCM equal to x square plus y square into x power 4 plus x square y square plus y power 4. So x square plus y square. Here any possible way to reduce this? Yes. Like this one term we solved in the first problem. Today's first problem. Listen one more time. I will say this. So x power 4 we can write it as x square the whole square plus x square y square plus y square the whole square. So it is equal to x square plus y square into, here what is the form? A square, here also b square, but which is missing? 2 is missing. What is the meaning of 2ab? ab plus ab. That means 2ab. Here x square y square, only one term is here. If we have one more term, then 2x square y square will come. So we can add one x square y square and we need to subtract one x square y square. So the value remains unchanged. So listen, x square the whole square plus x square y square plus y square the whole square plus x square y square minus x square y square. So the value doesn't change. The same way we need 1x square y square. So we will get which formula? A plus b the whole square. For that arrangement only we are adding one term and subtracting one term. So listen, x square plus y square into, now rearranging, x square the whole square plus x square y square plus x square y square. So 2x square y square plus y square the whole square minus x square y square. Got it? Which is equal to x square plus y square. Now comparing the formula with this. First three terms a square plus 2ab plus b square. On combining the first three terms, we are getting a plus b the whole square. So here a equal to x square, b equal to y square. So a is a plus b the whole square. X square plus y square the whole square minus x square y square. How can we write? Xy the whole square, which is equal to x square plus y square into, now it is in which form? A square minus b square. So it is very easy, no? A plus b into a minus b. So a plus b into a minus b. That's all. So LCM, one single line only they gave. We derived up to this. It's very easy only. The only main thing, we are getting the arrangement for a plus b the whole square. So just we are adding one term and subtracting one term. Then only we can get this 2x square y square. Okay. Then GCD what is given? X square minus y square. GCD equal to x square minus y square, which is equal to, which formula we need to use? A square minus b square equal to a plus b into a minus b. So here x plus y into x minus y. And then one more term is there, q of x equal to. We are going to reduce that q of x also. Okay, listen. Now q of x, x power 4 minus y power 4 into x square plus y square minus xy. Listen, x power 4. Shall we rewrite this as x square the whole square? So x square the whole square minus y square the whole square. Then x square plus y square minus xy. So here, which formula we need to use? The same identity. A square minus b square. A plus b into a minus b into x square plus y square minus xy, which is equal to x square plus y square, and again we can apply the formula identity a square minus b square equal to a plus b into a minus b into x square plus y square minus xy. So q of x also we got. Now we need to write the relationship between. We know that p of x into q of x equal to LCM into GCD. We need p of x. So p of x equal to LCM into GCD divided by q of x. So p of x value we are going to write here. Listen, LCM value I have written. These three terms LCM value and the last two terms GCD value. Now I will write q of x value. Listen. So q of x, this four values, correct? This four values because q of x is that only. I will write that also. So x square plus y square into x plus y, x minus y, then x square plus y square minus xy. Any possible way to cancel? Tell the values. X square plus y square plus y square gets cancelled. Then x square plus y square minus xy also will cancel. Then x plus y, x minus y, x minus y. So what is the required answer? P of x equal to only one term is here. X square plus y square plus xy. So this is the final answer. That's all. We solved all the problems in exercise 3.3. The next chapter, rational expressions, we are going to see now. Okay, listen. The same chapter only, Algebra, but section 3.4, Rational Expressions. It's very easy. See the definition. An expression is called a rational expression if it can be written in the form P of x by Q of x. That means ratio form, A by B, fractional form, where P of x and Q of x are polynomials. Both the numerator and denominator both should be polynomials, and the denominator value should not be 0. If the denominator value, suppose if it is 0 means, is it possible to get answer? No, the value is undefined. So only they are giving Q of x not equal to 0. This is one important condition. A rational expression is the ratio of two polynomials. Ratio means A by B form. That means A is to B in fractional form. How can we write? A by B. So listen, some examples. Rational expression. One expression, can you say? X plus 3 and divided by x minus 3. This is one example. Then one more example. This is one linear polynomial, no? So in quadratic polynomial, shall we write one example? X square plus 5x plus 7 divided by x square minus 6x plus 6. This is also a rational expression because it has a numerator as well as one denominator. It is in the form P of x by Q of x. And the Q of x value not equal to 0. Because it has two values, no? Quadratic polynomial, when we solve, we can get two values. So that two values not equal to 0. So these are the examples of rational expression. So clearly we need to learn this. An expression is called a rational expression if it can be written in the form P of x by Q of x. And this Q of x not equal to 0. And then, listen, reduction of rational expression. That means a rational expression P of x by Q of x is said to be in its lowest form when we can say this rational expression is in lowest form, there can be one condition. See the condition. GCD of that two polynomials should be 1. There is no common factor between the two polynomials. If there is any common factor, we need to cancel that. And then the last form is the reduced form. See here, 2 and x plus 4. Is there any common number? No. Sometimes, see, 2 by 2x plus 4 means there is one common term. What is that? 2 by, here 2 we can take outside. So x plus 2. This 2 and this 2 we can cancel. And then 1 by x plus 2. So here there is no common value. The GCD of 1 and x plus 2 is 1. So this is in reduced form. But this one not in reduced form. Compare this. 2 by x plus 4 reduced form. X minus 1 by x plus 1 reduced form. Because there is no common numbers. So this is one reduction of rational expression. So you need to think the reduced form means the last form should not have any common numbers. That's all. So see the book example. Example 3.13. Reduce the rational expression to its lowest form. Shall we do now? So x minus 3 by x square minus 9. Solution. First I am writing the question. X minus 3 by x square minus 9, which is equal to x minus 3 divided by x square minus 9. We can write it as 3 square. So which is equal to x minus 3 by this one, which formula? A square minus b square equal to a plus b into a minus b. Just write this, x plus 3 into x minus 3. So listen, is it any possible cancellation? Yes, x minus 3 gets cancelled. So what is the last answer? Here 1 by x plus 3. Now check this, whether it is in lowest form or not. Is there any common term? No. So this is in lowest form. That's all the answer. So this is the final answer. Answer equal to 1 by x plus 3. Shall we solve the second problem now? Second problem. X square minus 16 divided by x square plus 8x plus 16. Some students, they may cancel this also. 16 and 16. Don't do this. It is connected with subtraction. Here addition. We cannot cancel that. We need to apply the formula here. So x square minus 16 divided by x square plus 8x plus 16, which is equal to x square minus 16. Is it possible to write as a square number? Yes. So 4 square divided by, here this is quadratic polynomial. Shall we factorize this? What is the product? 16. What is the sum here? 8. What are the numbers? Can you guess? 4 4s are 16. 4 plus 4, 8. So what are the factors? X plus 4 into x plus 4. So the numerator, the formula we need to apply is a square minus b square. So a plus b into a minus b divided by x plus 4 into x plus 4. So 1x plus 4 and 1x plus 4 gets cancelled. And what is the last answer? X minus 4 divided by x plus 4. Now listen, only 2 examples there. Now exercise 3.1, first Roman, first question. Reduce each of the following rational expressions to its lowest form. Very simple problem. Let's listen. So x square minus 1 divided by x square plus x. Solution. X square minus 1 by x square plus x, which is equal to x square minus 1, we can write it as 1 square divided by any common term here, x square plus x. X is the common term. So x, when we take outside, x plus 1 we can get, which is equal to a square minus b square. Tell the formula, a plus b into a minus b. So x plus 1 into x minus 1 by x into x plus 1. Any possible cancellation? Yes. X plus 1 gets cancelled. And what is the final answer? X minus 1 by x. This is the required answer. Got it? Okay, listen. And today's homework is exercise 3.4, second Roman. That is the thing we need to do it in lowest form. This one need to reduce into lowest form. First Roman, second question. Okay. So exercise 3.4, first Roman, second question. You need to reduce into lowest form. You can use your textbook and write the full question, and then you can find out the answer. Okay. So here x square minus 11x plus 18 divided by x square minus 4x plus 4. Both are in quadratic polynomial. So first factorize this, the numerator, and then factorize the denominator, and then check for any possible cancellation. If there is any possible cancellation, cancel it. Then you will get the lowest form. Very simple problem only. You need to do that. Now the same exercise, third problem. First problem we finished now. Then second problem is the homework. And then third problem we are going to do now. Listen. This is also very simple problem. 9x square plus 81x divided by x cube plus 8x square minus 9x, which is equal to. Check the numerator. Any common term in the numerator? 9x, we can take it outside. After taking, what are the terms will come inside? X plus 81 divided by 9. 9 only. 9 9s are 81 divided by here. Any common numbers here? No numbers. Any common variables here? Here x cube, here x square, Here x. So x we can take it common. So after taking x as common, x square plus 8x minus 9. Now this x and x gets cancelled. So 9 into x plus 9 divided by, this is a quadratic polynomial. So we can reduce into factors. What is the product one? Minus 9. What is the sum here? 8. So when we multiply, we need to get minus 9. When we add, we need to get 8. Can you guess the possibilities? 9 and minus 1, is it correct? Yes. So x plus 9 into x minus 1. So here x plus 9 gets cancelled. And what is the last answer? 9 by x minus 1. Now check this. Whether it is in reduced form, that means lowest form. The GCD of 9 and x minus 1 is 1 only. No common numbers. So this is the last final answer. Now listen, the last problem in first Roman. That means p squared minus 3p minus 40 divided by 2p cube minus 24p square plus 64p. We need to reduce this into lowest form only. Shall we do this now? So solution, p square minus 3p minus 40 divided by 2p cube minus 24p square plus 64p, which is equal to. Here, since it is a quadratic polynomial, we need to resolve this. So what is the product? Minus 40. What is the sum? Minus 3. Guess the possibilities. 220 will not come. So in 8th table, 8 possible. So minus 8 and 5. Yes. So the factors are p minus 8 and p plus 5. Divided by, here what are the common terms? 2 is the common term and in variable p is the common term. So 2p we can take outside. After taking 2p, what are the terms will come inside? P square minus 12p plus 32, which is equal to p minus 8 into p plus 5 divided by 2p into, this one we can resolve into factors. The sum product thing 32 and the sum is minus 12. In 8th table it will come, no? So 8 4s are, so minus 8 and minus 4 will be correct. So p minus 8 and p minus 4, which is equal to, both the terms will cancel. And what is the final answer? P plus 5 divided by 2p into p minus 4. That means 1 by 2p into p plus 5 divided by p minus 4. This is also correct. If you can write like this, this is also correct. Okay, that's all. Okay, up to this, we are winding up today's class. And the next heading, excluded value, we can continue in the next class. And dear students, don't neglect any question. You need to learn all the questions. Up to date portion, you need to thorough. Okay, we can see in the next class. Thank you.